All right, on this short video, I'm going to show, this is the Proton NMR of the Diels Alder. I don't know whether it's exactly the same one that I gave you because I'm here at school recording this, and I left the Spectra back at home. But this is a Proton from one of the Diels Alder products from a previous year. But if we had actually taken our product, if we had done the reaction, we would have isolated and we would have gotten a Proton NMR much like this. And so we will have talked about this a little bit. All I did is the normal processing we would have done to get to the point of looking at this. And I've already changed the units here on the bottom to hertz, because what we want to do after building the two possible products on Spartan and getting their energies, that allowed us to see which was the more stable. And then we went ahead and looked at the dihedrals. Remember, we measured those because those by geometry correspond through the Karplus equation to a certain predicted J value. So we were able to predict J values for the two possible isomers using the Karplus equation. So now we're looking at the actual experimental, because we know how to measure J's. So when we're looking at this compound, we're going to be able to find the two resonances that are important to get J values from. And so also by this point, we will have already talked about the COSY, which allowed us to identify the two proton resonances. This is A and this is B. And we determined that because this was the methyl group. It was adjacent to this multiplet, which was C, and then we saw that C corresponded then to this one, which was B, and then that one correlated to this one, so we know this is A, B, C. So what we need to look at really is just A and B and measure the J's. So I'm going to expand just B for right now, and we'll go ahead and make that a little bigger. Okay, and so what we want to measure is this J, right, and this J. Those are the two J's that would be, and you know that from when we did the reduction and looked at it. So I'm going to come down here to the measure tool. I'm doing a horizontal measurement. So I'm going to measure from here to here, and it's 2.47 hertz. And then I'm going to measure from here to here, and it's basically 4.99 or 5 hertz. Okay, so those are my two J's. And so you can look at this again to make sure you get that data down. This is for Proton B. Those are the two J's. Okay, so now I want to do the same thing for A. I'm going to make this bigger. And again, I'm going to measure from here to here, and then from here to here. And that should give me the two J's. So I'm going to go to measure, horizontal, here to here, 2.12 hertz. Then from here to here is 4.94 hertz. Okay, so now we have the J values experimentally for the actual product that formed. And so what we need to do then is match those up with the J's that we predicted through modeling and the Karplus equation for the two possible products. Which does the experimental actually match up to? And that's the data that we use to see whether our prediction actually matched up to the experimental.